Look is like,
Yeah,
these guys are weird.
Yeah. And I thought I was weird.
Okay, so we're going to talk about proportions. Proportions are made up of what? Andrea?
Two different fractions that should be equal to each other.
Yeah, well done, well said. All right, and what are those fractions called? Those individual fractions? I'll give you a first chance. You'll recognize it as soon as somebody says it.
I'm probably wrong. Are they mixed numbers?
You were close when you said wrong because you had the right sound. Okay. Yes, Ben. Okay. Mira. With the ratios, right?
Oh,
Ratios, wrong. They have the same sound.
Okay.
Right? Okay. So, every ratio is a fraction. A ratio is a fraction. Now, that's not actually totally true. I mean, it is true, but you might not see it written as a fraction. And I think Nate explained this before. Like if it said the ratio of 1 to 4, right? The ratio, for example, ratio of 1 to 4, I could write it like that, or I could write it like this, 1 to 4, or I could write it like this, 1 to 4. Those are the three different ways you'll see it. Remember this? I mean, Nate explained these things, right?
yeah.
But Nate also said in his lecture that you always, in math, use which one? The fraction. That's why I'm saying the ratio is a fraction. Always use the fraction, right? Forget this stuff. But in words, they'll often use it like this. They'll say the ratio of, what? The ratio of boys to girls is 7 to 21, right? Or something like that, 7 to 21. The first number goes on top, the second number goes on bottom, right? That's how you write a ratio, okay? Does it make sense? First number on top, second number on bottom. Just like you'd write a fraction. You never write a fraction with, like if you wrote 1/4, you wouldn't do like this, right? You never do that. You do the 1 first, /4. So the first number goes on top, the second number goes on bottom. You know what I'm saying? Excuse me?
Isn't that the same thing? What are the
Yeah.
four-
What I was going to say, when you write a fraction, I've never seen anybody always write the denominator first, and then the line, and then the numerator.
Oh.
Most people start upstairs and they go downstairs, right?
Okay.
Move downstairs. And so that's the way it's written too. The first number is the upstairs. The second number is the downstairs, right? Okay. So let me just erase this part because that's not necessarily what I'm doing. Okay, so let's do a word problem where it says the ratio. Okay, we'll just start a few. The ratio. Sometimes they actually give it to you as the ratio, so you know that it's a ratio. The ratio of, I don't know, gorillas to chimpanzees. I'm not quite sure what the difference is, but other than size, right? Right? The ratio of gorillas to chimpanzees is 4 to 20. Okay? Period. If there are 180 chimpanzees, how many gorillas are there? Uh-oh, maybe there's only one R. Gorillas are there. Question mark. Okay. right, so it immediately says the ratio of gorillas to chimpanzees. Gorillas is the first thing it says, am I right? And it's a ratio. It says ratio is gorillas to chimpanzees. All right, the first thing before you actually write the problem is you write the map. Remember this? Remember the map? What's the map? Anna?
So it's gorillas to chimpanzees.
Right,
So since gorillas come first, gorillas is on top
okay, let's do it.
and chimpanzees is on bottom.
So this is my map. Gorillas over chimpanzees. Does that make sense to you guys? What?
Yeah.
Right? So the ratio, we know ratio is a fraction of gorillas to chimpanzees. Gorillas is the top part, upstairs. Chimpanzees is downstairs. That is my map. I always write my map first. And then now a proportion is going to be a ratio equaling a ratio, right? Right? I didn't write that down here. But a proportion is ratio equals ratio. Right? In other words, a fraction equaling a fraction, like Andrea said. Right? You with me? It all makes sense? Remember this? Sort of?
I was not in your class, so.
No, this was Nate. Nate taught this.
Okay.
Nate taught this before we separated, when we were all together. Right? But this should be familiar.
It is.
Yeah. But you'll see. You'll see what I mean in a second. But like, let me give you an example, Luca, just so that you're not confused. So a ratio equaling a ratio. For example, 1/2 equals 2/4. Remember that? So you have a fraction equaling a fraction. Now, is that true or false?
True.
And how do you know?
Because if you reduce 2/4,
If you do what?
if you reduce 2/4.
Right. You could reduce 2/4, divide 2 by 2 and 4 by 2, you get 1/2. 1/2 equals 1/2. But what is the other way? Cross multiply. Remember this, Luca?
Yeah, I remember.
Remember this? Where you say 1 times 4 is equal to 2 times 2. 2 times 2, 4 equals 4, it checks. So they're the same thing, right? And then that's how he first started in his lecture. And then he said, let's say we don't know one of them. Let's say we said x is to 3 as 5 is to, I don't know, 9. Okay? Right? And so we have an unknown. So what we would do is we would do this. We would do 9 times x. 9x is equal to 3 times 5 is 15. Right? With me? And then I would divide by 9. Divide by 9. X is equal to 15/9, or divide them both by 3, I have 5/3. Right? That's an example of using a proportion. Right? Remember that cross multiplying? You guys all remember that? So that's all we're going to be doing. We just have to set up the proportion. We have to find the first ratio, and then put an equal sign. And then we have to find the second ratio. Right? All right. So now the first ratio is usually given. Not always, but usually. So it says the ratio of gorillas to chimpanzees. Gorillas to chimpanzees, that's my map. So I know whenever I write a ratio, gorillas, the number of gorillas has to be upstairs, right? And the number of chimpanzees has to be downstairs. With that map, I'll always get it right. Always. So it says the ratio of gorillas to chimpanzees is 4:20. Gorillas 4, chimpanzees 20. Gorillas 4, so I'm going to put 4 here. Chimpanzees is the second one, 20 is the second one, so I'm going to put a 20 here. And then what do I put after that fraction? Equals, right? And then it says, if there are 120 chimpanzees, 180, excuse me. I was just testing you guys to see if you were awake. Right? Right? Okay. 180 chimpanzees, where would that put that? I put that up here, right?
No.
Why?
There's chimpanzees on the bottom.
Oh, right, this map. I forget about this map. That's kind of useful. I like that. 180, right? Oh, but there's nothing to put here. Oh, it says how many? That's an unknown. So I'll just make it an X.
You look like a commercial guy.
That makes sense though, right? It's pretty straightforward. So now what do I do? Yes. Is she right?
Yep.
All right, let's do it. So we're going to do this 20 times X. I like to put my X's first. Doesn't matter which one you do first, right? So I like to do the one first that has the X in it. So I like to put 20X, because I like my X on the left. It's just a thing, times 4 times 180. 4 times 180.
720.
You know what, I'm going to just show you a trick. What I would do if it were me, I might have actually reduced this fraction right away. But, you see what I mean? I could have reduced that to 1/5, right? And that would have made it a little easier, right? But if I didn't do that, let me show you another trick I could do. This is really kind of cool. Instead of multiplying 4 times 180, which is some big number,
It's 720.
that's pretty big, right? Right? Instead of doing that, what if I did this? What if I said 4 times 180? You with me? Isn't that the same thing? Now, what do I have to do to get x? Divide by 20, right? Everybody with me? I got to divide by 20. Divide by 20. Now, all I have to do is figure out, does 20 go into one of these? It doesn't have to go into both, because so wouldn't it be easier to figure out how many times 20 goes into 180 than 700 and whatever, right? I think that'd be easier. So, but look. Let me change this. 18 times 10 is 180. Would you agree with me? You see what I'm doing? 20 is 2 times 10, right? You guys see what I'm doing?
Yeah.
Does that make sense? What's 10 over 10?
20. Wait, no. 1. Oh.
So I get rid of it, right? 10 goes into 10 once, 10 goes into 10 once. Now really all I have is 4 times 18 over 2. Does 2 go into either of these two numbers? All right, let's do it out of the 4. 2 goes into 2 once, 2 goes into 4 twice. So my final answer, downstairs I just have 1 times 1, which is 1. Upstairs I have 2 times 18, which is 36. So suddenly I've got x is equal to 36. The way I did that is I kept it in numbers that were smaller that I knew. Does that make sense? Did I lose you guys at all?
Almost, but no.
When I do that, what are these called? These numbers that when you multiply them all together, they equal a bigger number. They are factors, right? They're factors of a bigger number, meaning you multiply them all together and you get a bigger number, right? Right? So by keeping them as factors, it was easier to reduce. Does that make sense? Than if I multiplied 4 times 180. Really? So my final answer is, this is a word problem. So I just say x equals 36, right? No. If somebody took the time to write a word problem, we have to take the time to write a word answer, right?
You could say there are 36 gorillas.
Okay, how many gorillas are there? I always go back to my last question and see what they asked. How many gorillas? So I would say there are 36 gorillas. Whoops. Am I spelling gorillas right?
Yeah.
Okay, good. All right, fist to 5. Did you understand that? Fist to 5? All right, good job. Good deal. Okay, so that's one example. Can I erase? Okay, yes?
Mike, do you take a picture?
You don't need a picture?
Don't be a little buddy.
I wanted to see if you'd take it anyway. Okay, so that's an example of a word problem where it actually says the word ratio, right? So when it says the word ratio in it, it's really easy. It's like, oh, it's a ratio problem. Wait a minute, it's a ratio equaling a ratio. It's a proportion problem, right? But sometimes they don't say that. They don't say it's a ratio problem. You have to sort of intuit that that's what it is. You have to figure that out. So let's say they gave you this. Ivy.
That's the homework.
Okay, we'll just, whatever, it doesn't really matter. I'll just do this one. Okay, this is a very simple one, but you'll start to get the idea. It says one cantaloupe costs $2. How many cantaloupes can you buy for $18? Question mark. So this doesn't say ratio, but it is a ratio, right? So first of all, what is the map, Lila?
It's, cantaloupe over dollars.
Okay, so it's going to be, it says one cantaloupe costs $2. So it's going to be cantaloupe, right? Cantaloupe over dollars. You with me? Does everybody agree with that? Yes.
Do we have, or if we have like a question like this in our homework, do we have to do the work because the answer is like showing itself?
Yeah, because that's a good question. Yes, because what we're doing here is, yeah,
It's showing
right. Everybody knows the answer, right?
8 plus 1. Well, then again, there's the whole 10 plus 1 is 20.
Right. So this, but a lot of guys, listen. A lot of times in math, the whole idea is to give simple problems at first, where you can create a system that always works. Does that make sense? So you want to practice the system so that when I give you hard ones, you know what to do, right? You know how to set it up. Because you guys, how many people know what the answer is? What, like Luca, what is it?
9.
Was he right?
Yes.
Right. Everybody knows that. Everybody knows that's the answer, right? But if I gave you something with decimals, then suddenly you might get confused. You might not know, well, wait, what do I do? Whatever. So let's work on the process. So we have our map. Everybody agrees that that's the map? Cantaloupe over dollars? How many cantaloupes do I have? 1. Costs how much? $2. And then what do I put here? Equals, how many cantaloupes, what goes here? X, can I buy for $18? Right? And real quickly, I just do my cross multiplying. 2x is equal to 1 times 18, which is 18. Divide by 2, and oh my God, Luca, you were right.
Yeah, did you ever doubt me?
And I'm done, right, Luca?
Yeah.
No.
No, you gotta write the answer.
Oh, I gotta write the answer. How many cantaloupes? So I go back and look at my question. How many cantaloupes can I buy for $18? I can buy 9 cantaloupes.
Did you ever doubt me? Yes.
Okay. Let's see if I can find a little more complicated one.
Well, yeah. What about doing like money conversion of it?
Okay. how about the currency in Argentina?
Wait, what? We're going into like.
I wanna say the
geometry?
exchange rate, is 73.
What does the currency even mean?
Okay, I'm just copying this. So here we go, 3, this is number 3. The currency in Argentina is the pesos. The exchange rate, where am I? Is approximately, APDROX, it's approximately $3 equals $1. Excuse me, 1 peso. $3 equals 1 peso, period. Okay, at this rate, where am I? How many pesos? How many pesos would you get if you exchanged $121.10?
How much is a peso?
Now, is this realistic?
Oh,
Is this a realistic problem?
Yes. Yeah.
It is. If you go to Argentina, right, and you spend 2 weeks in Argentina, and you're ready to come back to the States, you've got pesos, right? You've got a bunch of money in their money. You've got their money, and you're coming back to the States, and you don't want to just lose that money. So you go to a window where they exchange money, and you say, here's $121.10. It's very rare that you would actually just have an even number, not dollars, pesos, right? 121.10 pesos, whatever. But it's very rare that you have exactly just an even number, right? It's always going to be some odd cents as well. And unless you want to keep the cents, the coins for like a souvenir, some people do that. But some people don't, because they might have a ton of change. They might just keep one of each, and then they'll hand this to the person and say, what do I get, right? So how would I do this? What is the map? Okay, somebody uniquely different. Gideon.
It would be dollars over pesos.
Okay, great, I agree, because the first thing is dollars, second thing is pesos, so we'll do dollars over pesos. Okay,
So wait,
that's my map.
those are pesos? But we'll put it $21.
Yeah, it's pesos, but not dollars.
So if you exchange, oh, did I say, wait, what was the problem? Sorry, hang on 1 second. Oh yeah, that's dollars. If, in this case, we're about to go to Argentina, right? Or we just got there, and we thought, oh shoot, everybody needs pesos and all I have is dollars, so you go to that little window, you know, money exchanger, right? And you give them this, I don't know why you'd give them 10 cents, to be honest with you, but that's okay. You know, you probably
You're
just
moving there and you're changing all your money.
right, yeah, I just gotta change it all, because I don't wanna give them 10 cents by mistake, and then I'd lose that gorgeous dime, the value of that beautiful dime, right? Right? So what would I do? What's my first ratio?
3 to 1.
Can't you just divide with more by that rate?
Maybe.
No, it'd not be easier.
Well, but what I'm trying to, yes, but that's their question. But what I'm trying to do is I'm setting up a system, right, that always works. These are simple, right? But as they get harder, you can write them so that they're harder. So I just want to get the system set up, established first. So we got dollars, we got 3 over 1, right? 3 over 1 is equal to what?
$121.10.
dollars 121.10 over x. So now I'm going to do this, and we'll see if you guys are right. So 3x is equal to 121.10. Oh my gosh, she's right, right? She's right. To find x, we have to, 3 is multiplying times the x, we got to divide. Divide by 3. So now we've got to do this lovely little problem. 121.10 divided by 3. Everybody good at this? 3 goes into 12 4 times, so I'll write a 12 here, subtract. So 0, so I'll bring down a 1. 3 does not go into 1. 0. Bring down another 1. 3 goes into that 3 times, excuse me.
But you forgot if it's a decimal.
Oh my gosh. You're right. 3 times 3 is 9. Subtract 9, I've got 2. Bring down the 0. It's not really,
It's just gonna keep going
it's
on
going to
and
be,
on
yeah,
and
but it's
on
pretty
and on.
close to 7. It's pretty close to 7. I'm going to just put approximately 40.37 pesos, right? So I would say,
That's not a lot of places. I know, right? That's what?
how many pesos? I would get, where am I? Approximately 40.37 pesos. Yes.
If three, oh, never mind, sorry, I got some.
All right, so now just let me look at my homework real fast, see if there's any problems that are more complicated. Okay. Are we on 4, is that right? A recipe calls for 2 cups of cinnamon, almond, cinnamon, 2 cups of sugar to make 10 pies. Actually, you know what? Let's make it 11 pies.
I remember that time, Gary, when we were baking.
Just for fun.
Gary, why do you hate
Yes, we had, when we made those 30 pies for Thanksgiving, at one point, the recipe called for 2.5 teaspoons of cinnamon. And I turned around and Ben was in the process of putting his 2nd cup of cinnamon
Oh, was that
into the,
Keith's?
yeah.
I
Where did you get that much cinnamon?
I got one of those big ones from Sam's Club.
That was funny. That'd be a good phrase.
That was hilarious. I think Gita got your pie.
I know.
I think Gita got his
That
pie.
was a good phrase.
Um,
If it was a phrase.
She said it was a little spicy.
That was
Okay.
Yeah.
Spicy pie.
All right, so how many cups of cinnamon, right, would you need to make 80 pies? Right? So this is an example where it's a little harder to do it in your head, right? Because you've just got a few numbers. So what's my map? Do you agree? Brennan, do you agree? I mean,
Cups, 2 cups
what's your name again? Bella, that's right, Bella. I knew it wasn't Bella. Bella. So it'd be cinnamon, I have no idea if I spelled that right.
Cinnamon.
Cinnamon or cinnamon?
Gary, that's gonna get out of you.
Alright, well cinnamon over what? Pies, right? Alright, so that's my map. What's my first ratio? Are you guys with me? You guys? 2 over 11 equals how many cups of cinnamon? X over 80. Okay, so what do I do?
You gotta cross multiply.
Cross multiply. So I'll do my x's first. 11x is equal to, in this case, I'll just multiply it out. 2 times 80 is 160. Right? Now I'm going to divide by 11. Divide by 11. So x is equal to 160 divided by 11. All right, it's going to go into 16 once, right? Subtract, and then that gives me a 5. Bring down my 0, and it's 4, and 4 to that's 44. Subtract, that's going to give me 6. I'm going to put a decimal here and a decimal here. Add another 0, bring it down, 6, 5-ish, right? So we'll say approximately 14 and a half cups of cinnamon.
7.
No problem. No problem. 14 and a half cups of cinnamon. That's a lot of cinnamon. I would need 14 and a half cups of cinnamon. Right? So I think that's good enough. I think, and some of these will make you think a little bit, some of them won't. But that's okay, but I'd like you to use all of these as ratios, right? I mean, I'd like to use the ratio approach to solve all these problems. So that's good enough. I'm going to just end this lecture.